So now we have Caleb, who's going to talk about force multipliers and package management, how Homebrew maintainers can keep up with 10,000 and more packages. Really excited about this talk.
Thanks. And thanks everyone for joining in. I'm glad to be here to present about this. So I'll go ahead and jump right in. So to just a bit of preface. Let me try restarting my PowerPoint. It does that sometimes. This might just take 1 sec. Okay. Yeah, so I've been maintaining or helping maintain Homebrew for some time now, mostly within the core repo, pushing new versions and also reviewing. So this is just a bit of an overview of our ecosystem in terms of how things are laid out. So if you attended Mike's deep dive earlier today, we have the formulae on the left here in Homebrew Core and also our casks. So this is, you can think of this formulae as like open source stuff, and casks are proprietary or macOS specific things that don't quite fit into here. And these two used to exist as two different projects, which is why we've tried our best to kind of unify them, but there are still some quirks, I guess, about how these are unified. And so of these 5 kind of core repositories that we have, there's a lot of packages. So when you do the math, it's almost 12,000 different things to keep up with. And our maintainer team is generally in the tens of people. And of course, of that, not everyone's active every week. So, I mean, this really boils down to one big question. It's just maintainer time is generally pretty limited and scarce. So how do we make the most of it, and how are we able to keep up with this amount of stuff with just tens of people? And in the process of kind of thinking through this, I think it really boils down to 3 big things. So that would just be design choices in the package manager itself, and also our automation and tooling and culture and policy. So a lot of these things are things that Mike already covered in his deep dive, maybe in some deeper degree. So I'm going to be covering kind of a wide variety of stuff. It'll be kind of like a survey of many different topics. And I'll try to have these slides available later, and also you can reach out to me in Matrix later if you are curious about something. There are a lot of links in this presentation, so there are opportunities to explore more. But in the interest of time, I'm going to be moving kind of fast and at a pretty high level, I guess. So I'll start by talking about the design choices. So first of all, like Mike might have mentioned earlier, Homebrew is backed by Git, and all of the core logic is written in Ruby. So of course there are some benefits and drawbacks of that, but in terms of benefits, this is pretty useful for just hacking on it and experimenting. So if we want to try something new, anyone can open up their local copy of Homebrew and just start tampering with it and try things. And while this is a scripting language, so you do lose some speed, well, we've done some profiling, and it just turns out that most of our time is spent on I/O operations, or waiting for a compiler, or things like delegating to other processes. So in terms of Ruby being slower than something like C++ or C, we feel that it isn't that big of a deal, or so far it hasn't been too big of a bottleneck. And where there have been problems, we've implemented things like caching. So Bootsnap is useful for compiling expensive computations, and then also Sorbet provides type checking, so we get some of those assurances that you might expect more from a compiled language. You can still have that in Ruby, so that's pretty handy to have. On top of that, the Brew command line tool itself and all of our package definitions, all of those repositories are Git repositories. So updating them is just Git pulls. And if you decide to experiment with the tool itself, changing something or changing a package definition to try something, if it gets messed up, you can just do a Git reset to get back on track. And so understanding how to handle those repositories is also just, if you can handle Git, you can handle that. Mike did also mention that we have this install from API feature coming hopefully soon, so that users don't have to clone the whole repo and just to use Homebrew. So it might look a little like static site generation, where our development is backed by Brew or backed by Git, but users are still able to get something static and not have to have the whole repository. Beyond this, we are what you might call an Evergreen package manager. So we only support the latest version of any given package in our repositories. There are, of course, cases where it makes sense to have version packages. So GCC, for instance, we have GCC 11, 10, 9, 8, 7. Python, we have 3.10, 3.9, and 3.8 at this point. So, and then Go, we have like 15, 1.17, 16, 15, and so forth. So, of course, we have criteria for when to have those versioned formulae, but they exist separately from the kind of mainline package, so to speak. There, by default, you can't just install an old version of through Git history or something like that. And the reason for that really is just to reduce the testing burden, and it's just less of a headache. And so we wanted to minimize the situations where, for instance, something like a package A depends on package B, but package B has moved on to some new API. Package A also wants to update, well, they release an update to support the new package B, but then a user wants to install the old package A, and then we have to somehow make that work with the new package B. Or what if they install a mix of packages that needs both old and new package B? So things immediately get messy once you have to start supporting old versions of packages. Because this way we can ensure that basically a user has a working snapshot at any given time, whereas without this assurance, then all bets are off. So we have to support a lot more. So this saves us a lot of time, and especially CI and testing time, so we can focus that time somewhere else. And we'll get to that later in this presentation. Apart from this, it also reduces the need for package-specific knowledge, right? So I don't need to know that for whatever package, if it needs to be built in some particular way, or it's like before this version, it needs to do this, that, and whatever, and it has a certain quirk that it needs a certain flag or something like that. What's in that formula is always up to date and current for the current version. So we don't have to carry around patches to build older versions, or if we need to like rebuild older versions for support or things like that. So it reduces the amount of stuff we have to include in that that package definition as well. And then also we try to deprecate, disable, and remove older unmaintained software. So if upstream is not maintaining it, we don't want to be stuck holding it, just generally because that means that if there's something broken with the source code itself, well, there's no one to turn to fix it. So we would have to fix it. So, and also not to mention, just generally, if someone who was working on it doesn't want to work on it anymore, then maybe it would probably be in end user's best interest to find something else to use as well, especially if we as a package manager don't want to do it. So these are just two examples from our code base of formulae that have been deprecated or disabled, and just how that looks. So we can have like a date for it and also give the user a reason so they understand that. And also we have workflows to automatically remove disabled formulae, generally like once a year. So it's kind of a gradual phase out process. We understand that people use this in automation and sometimes need time to figure it out. So that's why we leave stuff disabled for a while before it gets removed. And then lastly, on design choices, it's extensible by default. So if you can host a Git repository, then you can host a Homebrew tap, right? We even have commands like brew tap new that will just create a new repository for you. And so hopefully that makes it easier for people to start hosting their own stuff. They don't have to go through our core repository just to be able to use and take advantage of our ecosystem. And if you need a package that has been removed or need an older version, we do have a command, brew extract, that can copy an old version out of our Git history and into a user's tap. Now, of course, that older version probably doesn't work out of the box because our DSL does change. The underlying macOS system does change. all sorts of things will change. So it's possible that that definition doesn't work anymore, but it is a starting point for users that want to continue using that and maintain it themselves. So the nice thing about that is that users can get that, but we as maintainers aren't the ones that have to have that responsibility. So we can pass that on to whoever actually wants to have that and use it. Not to mention, also the core logic of the application itself can be extended. So adding subcommands or just actual stanza blocks into the definition, those are all pretty handy. We even have some situations where some projects start as extensions or subcommands on top of the core Homebrew project. And once they kind of get mature to a certain point, we might talk about integrating them into the core app codebase. Our live check project and Homebrew Cask, like I mentioned earlier, were previously external projects, and now they kind of are part of the core app itself. So in this way, it's kind of a neat way to incubate stuff. Next, I'll move on to automation and tooling. So one aspect is that we just have extensive CI and checks for everything. So by reducing the amount of stuff that we have to test, we can devote more of that testing time, that CI time, to the remaining scenarios. So first, our CI, well, as you can see on the right, the CI works on all of our supported platforms. One thing it does is build and package the software. So Mike mentioned we do prefer to distribute binary packages that we've built from source. So that's where this happens. It gets built here. So we kind of have like a source recipe, and then it gets built in this process. Also, we run a minimal smoke test. So what we lack in products or package-specific knowledge, we at least try to have a minimal smoke test as part of this process. So if something is very obviously wrong, it gets caught during the CI process. And of course, as we identify more failures outside of this, we add more test cases to this the smoke test. And we also test dependent packages. So for instance, when we update the version of Go that gets, when there's a Go update, like I think right now we're dealing with 1.17.3, all of the dependent packages also go through a rebuild to make sure that that works. Or also with like Rust or Python, those kinds of packages that have really big dependency trees, not under them, but I guess coming out of them. We verify that dependents still build and also smoke test them, because sometimes just because it builds doesn't mean it works. And of course, we check for broken linkage. So that's looking for broken ABI compatibility and things like that. Also, we check packages for undiscovered dependencies, so linkages that go to things that might be sitting around, or we call it opportunistic linkage. And we try to crack down on it so that what's listed as a dependency is all you need, and that it doesn't just randomly pick something up. And also we check for relocatability. So can the built package be installed kind of in different places depending on the Homebrew prefix? So that's especially that relocatability part is something that we are continuing to work on improving. And then we also run a lot of audits and style checks. So those are just a few examples of the things we look for. And I think just as an overall, this is not really, well, not only just to have stuff built and tested, but it creates confidence. So we can say, okay, well, we're going through however many PRs a week, but we have some notion that there have been checks run on all of this stuff. So it's kind of, there's often a dichotomy between move fast and break things. Well, with this tooling, hopefully we can have both of those things. And I briefly mentioned live check earlier, but this is kind of what it looks like. It's generally a little regular expression that we have in our formulae that we have a tool, Brew Live Check, that can actually just run through all of these and tell us if we have outdated versions. And in some cases, it can even automatically open PRs for that. So that's pretty helpful. No more opening projects homepages manually and checking and all that. And of course, there are tools like Repology, and we do have integrations for that to scrape it. But sometimes it's more helpful just to go directly to the package homepage itself. And on top of that, we also, while we go looking for new versions, we also encourage packages or upstreams to push new versions to us so that we don't have to chase them down. On GitHub, we do have a GitHub action, the Homebrew bump formula action, that we already have a couple of packages when they have new updates and they run their CI workflow. It actually opens a new it opens a new PR in our repository with their new version. And so kind of like the time from when they go live with their new version to when that version ends up on our radar is on an order of seconds or minutes. So that makes it easier for them and also for us. And then Mike also talked about Brew Bump Formula PR. So yeah, anyone that has a GitHub account can update a package in a matter of seconds. And you don't have to know Git, and you don't have to understand the formula DSL to do it. And just to demonstrate that, I do have this pulled up right now. So I did check this before. There is a new version of libdrm, and we are shipping 24107 in Homebrew right now, and 24108 is available. So I have a GitHub token set through an environment variable. So if I just run this, it might take just a moment as it downloads the source package. Let's see. Yep. Yes, it's updating Homebrew. We do like updating Homebrew. Yeah, so it's downloaded the source package, gotten the checksum for it. And there we go. It's creating a pull request. And it went off screen. So let me go here. And that's the new pull request it created just now. And you can see it's already kicked off the CI to start the checks. So yeah, that took about 50 seconds. So pretty fast. I can see that my PowerPoint is messed up again, so I'm going to just close and restart that. Yeah. And then moving on from tooling, I'll just talk briefly about our culture and policy. So there is a common, well, I don't know how common it is, but there's a saying often attributed to Maslow's hammer. If the only tool you have is a hammer, everything looks like a nail. And in the past, people have tried to use Homebrew in a variety of interesting ways. And so one part of our policy, I guess, that has made maintaining Homebrew feasible is limiting the project's scope and objectives in the interest of sustainability. So there are a couple of examples. For instance, people have tried to suggest that Homebrew Cask should add categories just to kind of be able to allow people to search for a category and get apps in that category. We decided that, for instance, that wasn't very helpful because we as maintainers would have to maintain those categories, and then we would have to also agree on those categories. People will want to split, merge categories. It's a lot of overhead for a feature that really isn't Cask's core functionality or purpose. So that was something we turned down. People have also tried to download the stuff that comes from Homebrew, like download a package, take those shared libraries and actually ship them as part of an app, because their app needs, for instance, PNG quant or OpenSSL or something, and they want to brew install OpenSSL and copy that shared library and put it into their app bundle. And that works for some purposes, but then also when Apple Silicon came out, there were people asking, well, I want both, and both Apple Silicon and Intel versions, and frankly, our package manager just doesn't support that, and we kind of took a hard stand on that, just saying we couldn't handle that. And of course, there are better suited programs and package managers out there to support redistributing packages. I've listed Conan and VC package, but I'm sure there are others. And lastly, people have tried to kind of use it like a dependency manager. So, or if you're familiar with Python, kind of like a Python virtual environment. So that's something that we had to say we don't support right now, but we are talking about trying to support it. But there would be a lot of work that needs to be done. So just being able to say no is really helpful, even if it's just no for now. It reduces a lot of pressure in terms of maintaining things. Also, this is something that Mike touched on: prioritize maintainers over users. So avoiding burnout has been a pretty big, I think it's pretty important in terms of how we are able to keep up with all this. Just in terms of the amount of time and energy and attention that is required from maintainers, it's pretty helpful just to have that kind of support from the team that I guess maintainers are more important than just what we're able to produce. So one reason is that making a change to address a user need often leads to more complaints or requests for changes. Randall Munro has this, of course, given us this lovely XKCD that's relevant. And also sustainability is just part of a key consideration for any change that in both our core CLI app as well as in the package definitions. So if anyone wants to make a change, part of what we think about it as well, down the road or in perpetuity, who's going to be keeping up with this, right? Because especially if it's a really big change or really complicated, that could be a potential issue down the road, and accepting it could be setting yourself up for failure, I guess. Also, Mike touched on our use of Stalebot. Open issues in our issue tracker always indicate fresh or active issues, because first it helps with productivity, just being able to see what's being worked on, what needs attention, what needs triaging. Also, I guess just mentally, it can be overwhelming to look at an issue tracker that has so many different things that are open and may well be actual issues, but frankly, nobody's really looking at it, or doesn't have all the information we need to actually act on it. So being able to close old issues that aren't really going to be worked on is pretty helpful. And also, closed issues are still searchable. So if users run into an issue, they can still search it and see what has been said about it in the past. And of course, we can reopen those things.
Hey, Caleb.
Yeah, am
in the
I
interest
over time?
of time, there would be 2 minutes left for questions if you want to take them, or if you want to continue with the presentation.
Sure. Okay, I will go real quick. I just have one slide left. Real quick, maintainers don't owe users anything. So Mike did talk briefly about that. So go refer to his presentation if you have any questions about it. And he also has that blog post. And lastly, we want to encourage users. So that's documentation is really helpful for users and for formula writers, so they can have that package for themselves. They can run their own tabs. And of course, we have RubyDoc for core hackers. And lastly, we have the open source contributor funnel. So it's really helpful for turning users into contributors and maintainers. So just fostering that process, because we can't do it alone forever. And yeah, that's the end of my presentation. So, sorry, I kind of lost track of time. And yeah, I'm ready to take some questions if there's any. And of course, you can find me in Matrix afterwards too.
Thanks for the presentation. Yeah, there was a question on Matrix. Do you also have smoke tests for anything GUI or just CLI? If yes, what exactly do you check for?
Yeah, so generally we only check the CLI, so the stuff that are formulated. We don't have tests for the GUI cask apps. And the reason is because the casks, we can't we only facilitate download from the upstream, so we can't make any assurances about its functionality. It's just what someone else ships. For the formulae, the CLI stuff, it's generally just something we might run it with a test input. If it's a library, we'll build a simple program and things like that. So I hope that helps answer that question.
Yeah, so thanks again. I hope you can answer a bunch more questions in the matrix.
Yeah, absolutely. Sorry for the time.
No worries at all.
Yeah, thanks for having me.